Okay, so in part 2 of this video, we are still going to talk about secants, tangents, and chords in a circle, but we are going to talk about when they intersect on the exterior part of the circle. So there's actually 3 kind of rules or examples of when it intersects in the formula, but the rules are pretty similar. So the first one is if you have 2 secants. So notice I have one secant going through the circle and I have another secant going through the circle, and they are intersecting at point A. So we can actually figure out the measure of angle A. Your formula is half again, and it's going to be the measure of arc CE, subtract the measure of arc BD. So how I remember it, it's the arc furthest away, because it's the biggest, subtract the smaller angle. So that will always give you a positive number, and then you just half it. Okay? Now if you have a secant and a tangent, the formula is pretty similar. So you can figure out the measure of A. We're also going to take a half. Now it's going to be the exact same thing. So it's the furthest arc, subtract the next arc. So the 2 intercepted arcs. So this one, the measure of angle A, would be 1/2 of the measure of BD, take away the measure of arc BC. Okay? So again, you're subtracting and then halving them. And the same thing is true when you have two tangents. You can figure out the measure of angle A by taking half of your 2 intercepted arcs. So the first intercepted arc is a major arc, that's huge. So that would be BDC, and then your other arc would be BC. Okay? So those are your 2 formulas, or 3 formulas. So notice they have something in common. You are always going to be subtracting, and then you're always going to be taking your largest arc subtracted by your smallest arc. Okay? And so it's the 2 intercepted arcs wherever they are crossing. And those are your formulas. Okay? So again, these only works if it's dealing with the exterior. So notice how you're finding an outside angle. On the previous video, we looked at finding interior angles where we added, or when it hit once on the circle. So this is for if you're looking for an angle outside of the circle. So let's take a look at some problems. On number 10, or first off, let's kind of see what we have. I have a secant here and I have a secant here. So I'm looking at this first example, okay? So K, L, and M would be angle L out here, okay? So if I want to find angle L is going to be equal to half of this arc, take away this arc. So 140 take away 66. Okay, your big arc, take away your small arc, and then half it. Okay? So angle L, 140 take away 66 is 74. So half of 74, or 74 divided by 2, is going to be 37 degrees. So I know angle L right here, or angle KLM, is going to be 37 degrees. Okay? Let's take a look at another example. So in this case, I have a tangent line, and then I have a secant line. So that's going to be more like this example here. But I'm finding ABC, which is this exterior angle at B. And so I need my 2 intercepted arcs. So here's the first one, which I do not know, but here's the second one, which I do know. Okay? So there's a reason they gave us that 88. It's so we can use our knowledge of circles to figure out this big arc from A to D. So step 1 is to take 360 and subtract 88. And I'm going to subtract 62 to figure out what is left over. So 360 take away those 2 gives you 210. So I know this big arc is 210. So now I have my 2 intercepted arcs, so I can use my formula. So my angle is going to equal half of my 2 arcs subtracted. So 210 take away 62 is 148. So half of 148 is going to be 74. degrees. Okay, so they could give you, or they don't have to give you both arcs, but they do have to give you enough information to find both arcs. All right, let's keep going. On 12, this one looks like this third example where I have two tangent lines. Okay, so I'm going to have a very big angle, take away a very small angle. So P, R, and Q is this angle here. And so to find that angle, again, my formula, I need my two arcs. So I do know this huge 313 arc, but I don't know this smaller arc, okay? But you can use your knowledge that arcs have to be 360. So 360 take away 313 will tell you what this small arc from P to R is, which ends up being 47 degrees. So now I can do my formula. So my angle is equal to half of your big arc, take away your smaller intercepted arc. So 313 take away 47 is 266, and then we're going to half that for a total of 133 degrees. Okay, so not too bad if it's intercepting outside of the arc. Just make sure you subtract the big one minus the small one and then divide it by 2. All right, let's, I'm going to skip number 13. I think you guys can try that one in a second. Let's come over here to look at 14. So in all of these cases, I was finding angles. Okay, and I had a nice formula to solve for angles. So if I'm finding an arc, I'm going to have to work a little bit backwards. So I'm trying to find arc SW, which I do not know, but I do know my angle, and I do know the other arc. Okay, so I can't find this arc because I don't know what these other arcs are. So my formula, I'm going to put my angle is equal to half of your arc, take away your arc, correct? Looks like a smiley face. So in this case, my angle is going to go on the left side. So 40 is equal to half. Now I need my big angle, which is SW, or you could call it X if you wanted to. We could put X here. Take away my smaller arc, which is 75. Okay, I'm going to go ahead and change that to an X. So 40 equals half, and I don't know what my SW is, so I'm going to put X, take away 75. So similar in part 1 video, first you got to get rid of a half. Opposite of a half is to multiply by 2 on both sides. So 40 times 2, you would get 80 is equal to X, take away 75. I'm going to add 75 to both sides to get X is equal to 155 degrees. And that X value is our SW value. So it's a little bit trickier if they give you an angle measurement and you are finding an arc, because you have to work backwards and not just type it in the formula. So let's do one more together, get the hang of it. So this one wants me to find QU, which is this arc, and I know this arc, and I know this angle. So my formula is the angle is equal to half of your arc, take away your arc. So my angle is 35 degrees, so I'm going to put that on the left side, is equal to half. And I need my arc QU, again, you can call it X because we don't know it, or you could put QU, subtract 46. Okay, so to solve this, again, multiply by 2 on both sides. That'll give you 70 is equal to X, take away 46, add 46 to both sides, and you would get 16, 116. Okay, So notice this larger value has to come first in your equation because it's your larger intercepted arc, take away your smaller intercepted arc. Okay? So let's actually do one more together because I want to show you a case where it's not that way. All right, let's take a look at 16. So I'm trying to find MK. To find MK, you're going to need the bigger arc, and then you're going to need your angle. Okay, so let's set this up. So my angle is going to equal to half of your arc, take away your arc. So my angle is 56 is equal to half. Now you got to do your big arc first. So 160 take away your smaller arc, which I do not know. Okay, so in this case, x was positive up here, x is just negative down here. Again, same way of solving it, of timesing by 2 on both sides. If you double 56, you get 112, is equal to 160 take away x. So now these two are both numbers, so I'm going to subtract 160 from both sides, and that's going to give me a negative number, and that's okay. So you get negative 48 is equal to a negative x. Now the last step, there's just one extra one on this one, is to divide by a negative 1 to get rid of that negative sign. So your x is just a positive 48, okay? Because we cannot have a negative value for an arc length. So if you're looking for a major arc and you know the angle, it's fewer steps because you don't have to divide by a negative number. But if you're looking for a smaller arc, you're going to have to do the big number minus a small arc, which will result in you dividing by a negative. So why don't you guys try the ones we skipped over, which is 17 and 13, and then we'll go over our answers and be done with secants, chords, and tangents, intersecting, and circles. Press pause. All right, so I've zoomed in here on number 13. So first off, we are not given our angle, but I was given one of the intercepted arcs, but I was not given the other. So I actually could not do 360 in this one because I only knew this little semicircle. Okay, so semicircle is 1 over 180. I took away 67 and 94 to figure out that this little arc BD was 19. So then I could use my formula and do 67, take away 19, and then half it to get a final answer of 24. Okay, and then the last one was 17. And so first off, they gave you 191, which was your big arc. You did not know this minor arc, and you did know the angle. So we had to work backwards and say 77 was equal to the larger arc minus x, because I don't know this piece. Once you times by 2, and then subtract 191, and then divide by a negative 1, you end up getting 37. And so you know that this piece from F to H is 37. So then you can use that to find your final one from E to F. If we know circles are 360, take away this 37 and then take away this 191 will tell you what is left over for E to F to B, which is 132 degrees. Okay? So again, that is when you have secants and tangents intersecting outside of the circle. So if you've got an angle on the outside and you know it or you're trying to find it, and you know an arc and an arc, if you subtract them, that will find the angle for you. Okay? So thanks for watching, and have fun memorizing all of the different ways you can solve circles.